well, my name is Bart Palmer from the great state of Utah here in the great state of Texas today. I'm very happy to be here. And I've been doing data science for, I kind of helped with the start of educational data mining about 20 years ago, doing some stuff. My dissertation proposal actually got turned into an NSF grant that got funded. I was like, wow, that's pretty cool. Apparently that doesn't happen very often in the education realm or any realm. So it was really fun to start working on this problem of predicting software timelines. And to kick this off, there's a great analogy to this. The most intractable problem is why this doesn't, there we go. Oh, we might go one too far. Okay, so come from you from Salt Lake, and we're down here in Austin. If I were to drive home and I punch this into Google Maps, it's going to give me that it's going to take 21 hours on the best to get there, up to 23-ish hours, 22-ish hours. How many of you believe that I'd get there in 21 hours? Anybody? With certainty. You think I'd get there in 21 hours? I mean, I'm a developer. I can pull all-nighters. I can do this. I don't have to stop for anything. I don't have to eat. There's no pit stops. There's no nothing. No gas in the car. Wait, we just ran into problems, didn't we? So it's really not going to take that long to get there, is it? But that's driving time. That's actually movement time, right? That's what Google is telling us. And there's a whole lot that goes into this. I'm standing in front of the slide for you, so we'll take a walk. There's a whole lot that goes into this, right? We have the car, we have the driver, we have which roads, which intersections, all of that. We have to take all that into account, right? Maybe. Anybody remember the old way of doing this? Anybody with a paper map and junctions, and the little number in between, and you're trying to figure out, was that between this arrow and this arrow, or this arrow and this arrow? And then you had to hope that you knew the speed limit, and you add it all up, and you finally get, it'll take about this long. I see a bunch of smiles. I love that. It'll take you about this long to get there. And then you're like, well, wait, what if we take this detour? Oh, hang on, let me pull out the map and the calculator. And you have to calculate it yourself. But today we just punch it in, and we get this great estimate. Now, as I get closer to home, that estimate will get tighter, right, over time. And I'm pretty happy with that. It's fine for me now, but in 20 hours, I better have a very tight estimate of how close I am to showing up at home. Am I going to make it for dinner or not? Or bedtime for the kids or whatever. So this is kind of the story that we're going to look at today with predicting software. So everybody wants to know, when is this going to be ready? When is it going to be done? Anybody here ask that question or been asked that question? Show of hands. Okay, the ayes have it. We will go forward. Okay, so this is a common problem. Everybody's dealt with this. Okay, so is it easy to respond to? This is hard. The answer is tricky because there's so much that you have to think about. When an idea for a product comes in and you say, oh, let's see if that's even a real need, and you do your discovery. And then you have to make decisions. What does it do? What doesn't it do? And now we've got to design it so it's actually user-friendly and fits into the current UX, UI, all of that. Then we have to figure out how it's going to fit into the current technology. We have to put all that together. Then we actually do it, test it, and do it again. No, I'm just kidding. Test it, and test it, and test it, and fix it, and test it. And then hopefully we deliver someday. So there's a lot of help for the pieces up here. But these three down here, predicting this kind of process is really hard. It's a really hard part. And how many people are involved up here at a time? It's a small team, maybe. But when you get down here, you might have teams of developers running. And you have a lot of people. All of a sudden, it branches a whole bunch. So prediction gets very difficult. So the answer to that question is usually one of these, or pick your poison here. There's always an answer, but it's not the answer that the product people really want. You're right, this is delayed. And And so this is, wow, the cost of pressing buttons. So there is a cost to not knowing. So when you don't know when your product can ship, you don't know when you can start marketing. And if marketing can't market, then sales has a hard time selling. And if sales has a hard time selling, you have a hard time being employed. And there's some real consequences to this. And I don't have numbers, but probably hundreds of millions of dollars a year lost by not knowing when you can ship something early enough before somebody churns. You can't fix that problem. You don't know when the fix is going to be scheduled for the customer support part. So the whole go-to-market team is waiting to know when something will get delivered, but you can't tell it. Now, we're really smart engineer people, right? You'd think we'd figure this out, but we haven't. We made things up, like weird stuff like story points and mythical man months and very interesting things. So to get past this cost. So that's where Cardagraph founders, we put our heads together and said, well, maybe, now this is kind of a product journey as well. So this is really, it's a journey about data and about product. So put our heads together and said, well, the problem seems to be that the product people don't know how to look at Jira. So let's build a better Jira. And we'll call it JetStart. And it'll be easier to use, it'll track things, and it'll give better reports and all of this kind of stuff. That's fantastic. And we built it, and it was really cool. We had some users, and it didn't solve the problem. We couldn't tell. Product people still didn't know. Engineers couldn't say, it'll be delivered here on this day, or even this month, or quarter yet still. And so JetStart, it was a nice go at it, but it was kind of like on that trip home, I give you a different car. Is the car's important, right? It's going to get you from here to there. It's going to track the miles. It's going to churn through those miles for you, but it's not going to necessarily tell you when you're going to get there. You could put rockets on your car. I was thinking this through. What if I put a rocket on my car? I'm sure there's a hairpin turn I'd miss, and I would never make it home. That'd be a bad thing, right? So a better car doesn't necessarily tell you that you'll get home or to your destination any faster. So JetStart, it didn't solve the problem. So, like all good, humble founders, pivoted, and we called it the baby ugly. Stay. Okay, I think we're okay. Enter Tactical Operations Center. What a cool name, right? TOC. It's a place to see everything happening at once. Well, this is what it looked like. I hope that was because I pushed the button. We have an engineer here. This is actually co-founder on his wedding day. What a great picture. This was, so what this did was it looked at each engineer and said, well, maybe it's because we don't know what the engineers consider important. So we don't know what's actually getting worked on. So let's dive in and let's try and start looking at, say, Jira data or whatever tracking tool, ADO, and let's give you insight into what the engineer's doing. And that will help you know whether or not they're doing their job. They're getting it there. Well, it didn't do it, unfortunately. So back to the drawing board. This was kind of like, I don't know, a better tachometer. We could see into the car a little bit, but we're still down inside the car process. It did not facilitate the communication of expectations, which is, anybody had bad feelings in a company because these expectations didn't get met, or they got blamed, or something like that? Like, that's hard. It's hard. So let's talk about a little bit about product people for a second. They've got a big job to do. And since largely engineers in here, I'm sure you all appreciate your product managers. I hope you do. And they've got a tough job. They go through this. This is the cone of uncertainty. Anybody heard of the cone of uncertainty before? Anybody? Okay. This is a really cool concept. So out here, this is kind of the design. This is the discovery part. So we're trying to discover what we're going to build. And this is great. Constructs has a great look at this. The initial concept, product definition, marketing requirements, cool, and we're trying to squish the uncertainty of what we're going to build and when we'll deliver it all along this way. And then technical data stuff, detailed design. Well, those sound like the things that were listed up here anyway. That's a very small group of people doing this part. But then notice this. For the engineers, guess what? This is your part. How many helps are there? How many milestones are there? There's nothing consistent. It's different for every project almost, right? So what this becomes then is not the cone of uncertainty that narrows down and you nail it. It's like, boom, we hit that target like a dart. It's more like a bludgeoning. Hang on. Oh, man. It's going to go 2 slides, isn't it? Oh, there we go. It's like a bludgeoning. I couldn't get quite a blunt object in there. But the uncertainty stays this far, saying close, soon. It's sooner than it was soon last week, and it's sooner now than it was sooner last week. And we get there until about 2 weeks before you actually can deliver. And it's like, wait, I think we've got everything done now. Now we can deliver. But this amount of time doesn't help marketing or sales or anybody else. And that's a lot of bad blood right there. So this is the predicament of product because they are responsible for giving that date. And they come to engineers and they try and try and try, but engineers actually don't know how to talk about their own work. Anybody in here, like, estimation's magic, right? It's like, well, now if you're like me, when I go to estimate something, I sit down, I think about it. From my academic days, I do a little navel contemplation, just sit in the chair, stare at the navel, come up with an idea. Okay, I think this is what needs to be done. And yeah, okay, and I can see it working. And that felt like about 3 days worth of work. Okay, 3 days. You're laughing. Why are you laughing? Because it's like true, right? It's too close to home. We should be crying because this is too close to home. That's how estimation kind of works. There's just not really any hard data to it. So we're guessing a lot. And we don't know how to talk about our capacity. When somebody says, how much can you get done in a week? What do you say? Well, it depends. I'm not sure. I can get a lot done if it's easy. If it's hard, I'll still get a lot done, but it's harder, right? It's a different kind of done. So at this point, we started noticing that it was what product really wanted, what product really needed was just clear expectations. Give me a date that I can kind of count on, and if it moves, tell me, right? That's all they're asking for. Please, they're on their knees begging for this. But engineers don't know how to talk about it, and it's hard. It's kind of like marriage. If you don't know how to talk about the problem, yeah, it's really hard. And so we need to be friends. So enter Cardagraph. Cardagraph all of a sudden pivoted again and said, we need to try to give these estimates. We need engineers, they really don't know if they're ahead or behind necessarily, but we can start pacing them. And so we start looking at the engineers and we say, are they ahead of pace that they normally do? Are they on pace or are they behind? And then if you look at the aggregate of all of that, maybe we can tell if the project's ahead, on target, or behind. Kind of a cool idea, right? But this was kind of like looking at a driver going home and saying, how fast do you drive? Ooh, we'll make good time with you. How fast do you drive? Oh, we won't make so much good time, but we'll enjoy the ride. We'll see the scenery. Where if you're driving, we might not see it blurring by, right? And then we keep track of what your pace is, and are you driving slow or fast? Now the problem is there are like 18 drivers in a product going forward. It's not just one person at a time. So that's really hard to calculate. It's really hard to understand. And to be honest, what does it, like, this tells you if you're headed to your destination, but does it tell you when you're going to deliver? It still doesn't quite do that. It doesn't do it. So, another micro pivot. And we get to 3, 2, 1. We get to this idea of, well, let's go farther back in time. Let's predict the future from past activity, from the past activity. So we started looking at close rates of tickets of tasks, and this right here, this calendar here, this is kind of like what they're assigned. Everybody's assigned. It's still a view down inside. It's like what cylinders are firing, and what are they responsible? How much torque they're responsible for each time. Down here, we now have a calendar. This changed everything. This calendar view right here, this red, because it's easy to see, starts about the second week of September and ends the first week of November. All of a sudden, product people went, whoa, really? And we went, yeah, we think so. We think so. So this started communicating with the product people, and we said, oh, this is a big deal. That's all they really want. And if the date's going to move, it'll update for them. If it slows down, this starts moving. If it speeds up, this end moves back. So we found the answer to the question of product people, like the crux of what product people can use from engineering to know how to organize the rest of the go-to-market team. And the fun thing is with, everybody's familiar with Occam's razor. Okay, it's the simplest explanation usually suffices, or that's the real reason for it. But what does it mean to be simple, right? Simple means that it's as complex as it needs to be without being more complex. So that's going to be very important here in just a minute. Where's the start? Oh, okay. I have till when? A while. Okay, good. We have a lot of time here. So then we came to this part right here, Cardagraph in its current incarnation. We took that idea of a calendar and we turned our insight into wait a second, was that the next slide? No, we went one too far. Okay, workflow transitions. So the fun thing is that there are a billion ways to measure size of tasks and all kinds of things, right? But what we found was that they're all different. So we have a lot of data people in here. If you had to choose between a measure that was objective versus a measure that's subjective, which one would you choose to run statistics on? Subjective? Oh, objective. Okay, all right. Anybody want to disagree with that? Like, if you have the choice, wouldn't you rather use something objective? So if an engineer is kind of thinking and saying, well, this is, so Julianne over here estimates this task at being a 3. Well, she's a senior engineer. She's going to estimate this task to be a 2, okay? And John over here, 2J name's great, I've done this. Okay, John over here estimates it to be a 5 because he's a junior engineer. It's probably about that. That's how they view those problems, right? Now, if John estimates it to be an 8 or higher at 13 or something, Fibonacci, out there, and then what are you going to do with that task? What's John going to do with that task? If it's so big, you're going to break that up. So you're going to create 2 or more tasks out of it. So now John has more tasks to do, but at a lower point value each. And Julianne over here has 1 task at 2. And so it's not fair, right? John has more to do. He's got more tasks. Well, but Julianne, they'll move through them maybe about the same. A task will probably get moved through at about the same amount of time. Because Julianne has more experience, she'll probably get it done faster. And John will move through slower, but he also has more tasks. So all of a sudden, task count became a very important thing. How many tasks you have. But then we were looking at task completion. And how far into a project start do you get your first task completion? I I actually don't know. I mean, it's different for everybody, right? But often done is like a week or two in when the ticket finally gets through testing and it's done. And it can be that far in. But if you're in a project and you're trying to track progress and you only get updates every week or every 2 weeks, you finally close all the tickets or whatever, they finally move to a closed state, then you get data so sparsely. The data frequency slows way down. And so we thought, well, hang on a second. Let's look at what we're actually measuring. Anybody here use software that doesn't have tickets go through a sequence of transitions? A set of transitions like statuses or stages or states, okay? All of a sudden it dawned on us that all we're doing, we're not predicting how fast you program. All we need to look at is how fast you move your tickets through the workflow. Let that sink in for just a second. We're actually starting to look at the measure of the progress through the process instead of how hard the process seems to be for people. This, I had to wrap my head around it 3 or 4 times when we realized this. Well, let's use workflow transitions to now indicate progress through a project. And it was the coolest thing. So all of a sudden, we can map it out. We can say, oh, well, a task takes this many transitions. So we know how fast you're moving through those transitions. We know how fast your project will get done. So as a traditional Gantt chart here, this is pretty cool. But how many of you have, when you usually build a Gantt chart, you go in and say, okay, here are all my projects. And then how are the bookends calculated? How do you do those? It's a what? Sorry, still didn't. Oh, critical path. Right, dependencies and stuff. But the length of each chunk, is still, I don't know. You're going off from estimates. Yeah, you're putting your finger in the wind, trying to figure it out. It's like, which way's the wind blowing today? Is it cold outside? I don't know. My fingers get stiff. I don't do it as fast, right? So it's all this guessing. This Gantt chart is very different because none of these widths, none of the lengths are human input. Absolutely zero human, well, I can't say absolutely, because you tell us how big the project is, we'll tell you how long it'll take. And it's that simple. Okay, it's not that simple underneath, but it's that simple in the interface here. It's that simple to use because we go in and we harvest your JIRA data and we calculate all of this, we run our models, and we know how long it'll take you on average. Now, if this is a future project, this is all past stuff. These are real numbers. So this is how long it actually took this customer to get through all of these projects. This is how long it took. Now, not everybody finishes a project. Did you guys know that? You laugh. You laugh. This was new knowledge to me. I'm like, well, yeah, we finished the project. We get all the tasks done. But what we found was that people get about 80 to 95% of the tasks done and say, we got to ship. And it's done. And the tasks hang open. And the project hangs open. And I'm looking at it going, how do I know how to close? When do they ever close anything? Turns out not everybody does. And that's okay. We take that into account. We figured it out. And we'll close it for you if you wait long enough. So some of these never really ended. And so there might be a couple of week buffer here. But you actually tell us how long to wait to close it. It's kind of cool. Actually makes it really easy for you and me. But all you can do in a future project, you come out here and you click, and you're like, I want a new project out here in the future. And you click and you put in the project name and you say, okay, it's going to be about this big, t-shirt size. And I'll tell you how long it'll take you, approximately. And you can tell me how many resources you're going to put towards it. And I'll say, oh, cool. Then you should be able to move through it a little bit faster. If you're not very certain about it, I'm going to lengthen it out. If you're very certain about it, like you know that you've got the solution and that you're going to nail it, you've got the design, then I can shorten it because it's not going to take a lot of iterations through development testing, right? Through those processes. So this is some really cool stuff. You can't come in and say, oh, click and drag it down here, or click and drag it out this way. It moves as a block. You can tell me when you're going to start, but that's it. That's it. And then you get to enter parameters that then influence when it will end. That's kind of crazy. Now, for the product people in here, let's see, up here, yes, and there's somebody over here, yes? Our product friend, product managers. Okay. How many hours a week do you spend trying to get information from engineers? Wait, everybody else laughed. She shook her head, and everybody else laughed. That's a really cynical view, I'll tell you guys. Jeez. No, it takes you a long time each week to update the roadmap and when things are going to get done because you gotta go in and shuffle everything. Yeah, here you don't have to because it just pulls from data and it keeps it updated. And when you bother the engineers, or engineers when you get bothered to re-estimate something, are you on task? Are you getting it done? You're not. You're spending time doing other work, and it's just pushing that delivery date out quite a ways. So let's stop that madness, and let's just drop in, use data to predict when this is going to happen. Okay, this next view, this line of numbers up here, it should scare you at a couple of spots. It's bright red, right? I don't know if you can read it, 571%. What? That's freaky. Over here, let's see, there's another one, 36%. That looks like a bad week. Let's see, right around here, 43%. That's an interesting week. That was, June, end of June, okay. Something else happened here, July, and we're running at 200% out here. That's kind of crazy. What even does that mean, right? Okay. Now this was the second chart we built because people didn't actually understand this next one. So we built this so it's familiar. Okay, you all know what this says. Now to prep you, take these and make a stacked bar chart out of it with each project's effort mapped in each week, okay? Does that make sense? Any questions right there? Okay, no, okay. Okay, here it is. This is your capacity chart. The capacity chart has a couple of cool features. You can see kind of Gantt, okay, and it's done, right? You can see the path. You can see the Gantt chart in this. But this capacity chart tells you what was being moved in Jira that week. This is all past data. This is end of the year. So what traditionally happens? Anybody want to guess what was happening between middle end of October and middle November right here? Why is that so much higher than this line, this reference line? Anybody worked a little overtime over those days, trying to get end of the year release, trying to get something done? Yeah, that's exactly what's going on here. And then we get days off, right? And we don't get a whole lot done. That's a happy time. But guess what? You paid for it. You paid for it. You ran faster than you really should have so that you could sit around more than you should. And we see these ebbs and tides all the time. Now you can run hot for a little while. That's okay. Anybody felt burnout before? I see a lot of heads. Burnout is a real thing. Burnout is awful. This reference line is your company's, or this, whatever is represented in these projects. It's the reference line of how much capacity you have had in the last few weeks, last 12 weeks. All of a sudden now, engineers have a way of talking about capacity. Is it perfect? No. Transitions aren't perfect. Could you game this? Oh yeah, I'm moving it back and forth, back and forth, back and forth, back and forth. I get a lot of transitions done, woohoo! But did it move anything to done? No. So you actually just raised your transition rate, so you just kind of hurt yourself. You just raised this line a little bit. That's a bad idea. So it takes care of how, it helps the product people know what's being worked on, so you can check priorities. Engineers sometimes want to hide things. Just like I estimate in a perfect world, and then real life happens, and it takes me longer than I ever thought it would. And we also don't want to be behind. We want to be on time. And so that's why we don't let anybody know, and we get that blunt object of uncertainty, right? We don't want to tell them we're behind. We don't want to take that hit until we can't hide it anymore. And then we're like, yeah, no, it's not going to show. And that's painful. And that costs real money. That costs real social capital inside the company, and it hurts. So if we can communicate better, now we have a way of talking about capacity, and we have a way of talking about progress, and we have a way about planning. So for a product person, imagine out here to the right, all of a sudden everything kind of goes doop, 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 and there's a lot of white space underneath that line. What can you do? You fill it up. Yeah, anything you want. What's next on my priority list? So you flip back to the other part of Cardagraph, and you're like, oh, this idea is at the top. Schedule it, start it there. It'll take this much capacity. And when that one's done, I can schedule the next one. When that one's done, I can schedule the next one. Or I need to run these two together, but I can split the capacity because I have 2 teams or 4 teams or whatever. I can split it up and run several projects. And as long as it's kind of in this area, you're going to be okay. You're going to be okay. And you can tell somebody it'll ship around this date. And if it starts moving, well, we'll keep that in. We'll give that one next. So now you understand those numbers. 204% of average here, 5% of average over Christmas, right? And if you know that those dips are going to happen, you could actually move projects and say, you know what, we traditionally don't do anything over Christmas, so let's just give everybody a break and let's pick it up after. But I know that it'll happen because I can see what we're used to doing, and we can do a really good job of it. So this is the other view of Cardagraph. This is the status view. It's the same data. Here's each project. We can see how many tickets are done. There are a bunch maybe in progress, but this is how many are done. And then over here, we can see that this is kind of an on-target, on-track date. Okay. This one here, it just moves. You notice how there's no little arrow at the bottom here versus this one here. Okay. So here, this is just a project that'll get done, and we're okay knowing that it'll be done around April 27th, 2024. That's a cool date. That's a good date. It's plenty far away. We can take care of this. This snapshot was from a few months ago. This project, same time. It should finish about the same time. I don't know why they're all 71. That's really crazy. Okay. Example data, right? This one, though, was one that we committed on October 4th, for October 4th delivery. And then scope creep happened. Or we completely missed the boat and we had to completely re-engineer the whole thing. And so it pushed the date out. This is the delivery, this is the estimated delivery date based on what work is left to do. This is the delivery date that you chose as kind of a line in the sand. We put a postmark out there. That's all it is. That's all it is. But now you can see that you have slowed down, and this project needs some attention. What do you do at that point? You usually go, you have the hard conversations. Okay, why is it slowing down? You can click into it. You can look at the tasks. You can look at the activities of the tasks over time. And you can say, oh, we really slowed down on this project right here during these weeks. Why is that? What happened? Oh, we had that other priority. Okay, that's understood. So now we need to revisit this, and who did we promise this to? We can go back to them and say, guess what? It's going to be out here. But we know that it should probably be delivered by April 27, unless something else happens. Just like Google can say, oh, you're 5 minutes from home, and then I get a flat tire. Or I've got 21 hours and I'm in a hurry and I get pulled over several times on the way home, right? We can't predict everything that'll happen. Neither can you, and that's okay. But we can get you as close as humanly possible today, or computer possible today, without changing the engineering process. We just watch the engineering process. We're not asking engineers to do anything different. If engineers in your company don't actually move their tickets, I can't tell you how many times people have said, our Jira data is awful. Our ADO data is awful. I heard a couple of smiles. Okay. It's terrible, and you're right. According to what probably should happen, it's probably bad data. It's probably really awful data. But what is the delivery timeline? Do we deliver down to, I could calculate this to the millisecond, and we want to bet on that millisecond accuracy? Yeah, me either. Because we're humans. Train of thought. Whew, derailed. That's okay. So where was I on that? Bad data in Jira, yes, but I don't care. If the Scrum Master is the one that moves it at the end of the sprint to close out the sprint, I'm okay. Now, your estimates within a week are going to suffer maybe just a little bit, but does anybody really need to predict that closely anyway? No, so we don't have to be that accurate, but we're way more accurate on dates than a quarter. Or if we get everything else done this year, anybody heard this one? If we get everything else done, then we can move on to the fun project. Right? Now this is another thing. If you bless you, if you give us your development operating budget for the year, we'll tell you how much the project's going to cost based on how big it is. And over the course of the project, we leave away the original estimates, size and all of that kind of thing, and we look at just this project. How's it trending? How's it going? How big did it actually get? So the closer to the end of the project, these numbers become actual numbers of how much time you're spending on this project in your year. What proportion of your year, your capacity is put towards that project. We can tell you that from the very beginning. As a matter of fact, when you set up a new project, this is a new idea, this is even before idea, you create this idea, and then once you've added a plan size, an idea size, then you can go plan it and it'll put it on your timeline. You give it a date, it drops into those other views. So you can tell us about this idea that you have, together with some senior engineers, you go, or the architects, you say, oh, how big is this? And we have extra large down here, you just can't tell it. So this is a smallish company, a fairly small development budget. They're going to do a project called monitor parsing. Anybody ever heard of that? Yeah, me either. But it has a value, estimated value of a very specific number that ends with a 3, but almost 100,000. That's cool. But if it's a medium-sized project and it only cost me $4,000 to make, well, what's your ROI? We know right now. We know before we even schedule it what the ROI should be. Now, will surprises happen? Yes. But we know it'll take about 8 weeks to do on an average capacity for your average project. I mean, average, whatever we're calculating. So that's a pretty cool thing. Now, for product people, this is like pure gold. They go, wow, it's amazing, and I don't have to change anything about my development process. I don't have any control over the developers anyway. I don't pay them. I don't tell them what to work. I don't tell them how to work. I'm in charge of queuing it up and getting the work through, and this solves their problem. And we don't have to bug the developers. Take them off from the development to estimate and estimate and re-estimate and re-estimate. So all of those things combined make this a solution to a ubiquitous problem, an intractable, ubiquitous problem. We talked to some CTOs and they're like, wait, you're spying on my people. No, actually, jellyfish spies on your people way more than we do. Way more than we do. So that's about it. There are a lot of whatabouts, but whatabouts. And I invite you to ask some questions here in a second. We learned a lot of things. We learned a lot about software development and product relationships. That was huge. We learned about what the real problem was between, and largely it's communication. I've seen spreadsheets from some customers, spreadsheets that the engineering leadership gave to product, saying, okay, this is where every project is, and this is how it's going, and all of that. And I looked at it and I was like, whoa, I can't make heads or tails of this thing. I have no idea. And that's what somebody that isn't a developer is supposed to interpret and come up with these timelines. Wow, That's the data they've been working with. They've been calculating mileage by hand over and over and over. And so today we've got the Google Maps of product management right here. So measures that are helpful for one part of the process. Story points might just be helpful for planning your sprints. That's okay. That's fine. Don't take them away. But I don't need them. But if it helps you, great. Good luck. I don't know how we ever came to packing 3 or 4 different ideas into one number, but wow, that should really bother anybody that's a researcher. Use a measure that's as objective as possible. Try to stay away from things that just don't speak to the actual goal. If you're measuring a process, measure the process. You don't always have to measure, like how many of you pay attention to the cylinders as they're firing as you're driving down the road getting to your destination? Every individual cylinder. It's like, I don't know. But on average, they're performing pretty well. I'm going to get there. And that's okay. So the right level of granularity, the Occam's razor, get to that sweet spot. And those are some of the great lessons that we've learned.